So after a couple really, really long videos, hour-long videos with a lot of examples in them, I'm just going to reward you with something really short right now. 8.6 is just kind of doing a recap of everything you've done so far and trying to come up with what are the things you need to think through when you develop that plan to solve the integral that's in front of you. Um, so the first thing, don't forget your basic integration techniques. Let me write that over. Integration techniques. Basic integration techniques. We kind of went over these in 8.1. This is, power rule, ln, your e to the x, some of the more simple inverse trig functions like the 1 over x squared plus a squared, the tan inverse, you don't want to get so caught up that you forget some of those basic integration techniques. Always look for that function derivative pair, right? And that will always work as long as the derivative part of it is not in the denominator. The derivative part must be in the numerator if you have a fraction. Remember that. Because then you have your u sub. Again, don't get caught up in everything else that you forget. Hey, wait, I can do basic u. You should always be looking to see if you can just do a basic u sub first. We did see some techniques where a little algebra manipulation allowed you to do u sub by, say, breaking up the fraction, because if I needed it to be an x plus 2, so for example, suppose I had x minus 1 over, or 2x minus 1, there you go. Let's do 2x minus 1 over x squared plus 5x minus 3, right? Okay, if I was doing the integral here, I would first try to look at u sub. To do u sub, I need 2x plus 5. We did learn that even though I don't have 2x plus 5, I can rewrite negative 1, right? So there's these algebra techniques to get us what we need as plus 5 minus 6, right? Because what's 2x plus 5 minus 6? Isn't plus 5 minus 6 negative 1? That allows me to then rewrite it, and maybe I can solve, and I'm not saying it would work on this one, but I might be able to solve it another way. That's just a technique. I don't think it would, because then you have negative 6 over that, and that may not work. But again, these ways to complete the square, these algebraic techniques. So 3, I'm just going to put know your algebra manipulations. How can I rewrite the integral that's in front of me using algebra manipulations, or how can I rewrite it using trig identities? Right? And when we talk about trig identities, always look for that cosine sine pairing, that tan secant pairing, and of course, cosecant cotan pairing. These trig pairs, if you can turn everything into cosines and sines, sometimes that works nice. If you turn them into tans and secants, sometimes that works nice. But both algebra manipulations is about rewriting your integral into something you can actually integrate. Always, if you have a product, can I do integration by parts? As long as the one you set to dv can integrates into something so much easier than what you had, this integration by parts works really nice. So look for integration by parts if you have a product. look for your square roots of, x squared plus something. Or look for x squared minus something. These are your trig subs. All right? Or you can set up your rectangle and throw it into a trig function. Is it irrational? Is it a rational expression? Is your function a rational expression? In which case you have to do the partial fractions. Keeping in mind that you can do it on an improper as long as you use long division. Can be done with improper rational expressions if you use long division. All right? And often you need multiple. So after you do your partial fractions, you might have to use U sub. You might have to use an inverse trig. You might have to do something else along the way. Something doesn't work. Don't get stuck trying to make that one thing work. Try something else. So again, short video, practice. At this point, you can start working on that lab. Looking at on lab 4, looking at those integrals and saying, okay, what's a way I can go about solve this? Use your partners to help you. And you can use 8.6. The homeworks in Math Lab are great because they're not from a specific section. They're, when you did everything in 8.5, you're using partial fractions. When you did everything from section 8.4, you were doing trig substitutions. So this is, now you have to look at it, which is what you're going to have to do on the test. Now you're going to look at it and you've got to figure out how to go about integrating. Okay, so again, promised you a very short video. Best thing I can tell you at this point is practice.